Hey everybody, so we've been talking about chemical reactions in science class, and specifically the chemical reaction that happens when sugar is burned. And actually last week some students got to do this involving a test tube, some sugar cubes, a Bunsen burner, and they took several observations to see what would happen as we burn sugar. Here's a little rundown of what happened. When we burned the sugar quickly turned to a liquid. It was bubbling, so that means there was a gas that was being produced. As it turned to a liquid, it also became a little discolored. It was no longer white, it became kind of a light brown, and as it started to thicken, it became a darker brown. And what we noticed actually is as it was burning, there was also some production of steam or smoke or other things coming out of the test tube. What we later found out that was steam is there was water droplets on the edge of the test tube. Afterwards, we broke open the test tube and we saw that this black stuff left over took up a lot more space than the sugar ever did. While the sugar took up about 1/3 of what was in the test tube, now the test tube was almost completely full, in some case overflowing, with this solid, flaky, bitter-tasting black stuff left over in the test tube, which was a lot different than the original properties we observed from the sugar. Okay, so what's going on here? Well, to know what's happening in the chemical reaction of sugar being burned, we have to look at the sugar molecule itself. We said in class that the sugar molecule is C12H22O11, meaning it has 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms. We built this molecule in class so we could kind of see what it looks like. When I burn something, we have to think, okay, it's always reacting with something else when we burn something. That is a common chemical that's found in our atmosphere, oxygen. To know this, if you ever lit a candle and you take a jar upside down and snuff out the candle flame, you're taking away that fuel source in the atmosphere, oxygen gas. So the oxygen gas molecule is O2, which means it's made of 2 oxygen atoms. So the chemical equation is C12H22O11 plus O2. You have oxygen gas and sugar reacting. Now, over time, what we saw is droplets forming on the edge of the test tube and steam emitting from the top. Well, this is your water. This is your water. Water vapor mostly, but some of that water vapor condenses on the sides of the test tubes as it's traveling upward and turns into steam, but then it quickly evaporates and goes into the atmosphere as water vapor. Water vapor is just vaporized water. It's water in gas form. We can't see it, can't detect it, but it's there in the atmosphere floating around. The other gas that's produced, which is in the bubbles, that's kind of popping and bursting and crackling as we're burning the sugar and it starts to change that light brown color, that's carbon dioxide, or CO2. That's 1 carbon and 2 oxygen. So that just begs the question of what is left over in the bottom of the test tube. Well, in the bottom of the test tube, all that black stuff, that's just like leftover soot. That's leftover junk that we weren't able to burn off in the reaction. It never had time to fully react with the oxygen. It leaves behind waste. That waste in this case is carbon, the black, chunky, flaky, bitter-tasting stuff that's left over in the test tube. When we break it open, we look at it, we see that there's a lot left over. It's expanded, but it's very porous, which makes it lighter than the sugar originally was in weight, but it took up a lot more space in terms of volume. It occupied almost the whole test tube. So when we look at this reaction in full, we have C12H22O11 plus O2, and it gives you water and carbon dioxide. Now this equation isn't balanced. If I wanted to balance it, it would look like this, which means I'm just changing the coefficients in front of the molecules to make sure that I have the same number of atoms on each side of the equation. This is something called the law of conservation of mass, which just says that the mass in the beginning of a reaction must be conserved at the end of the reaction. We can't lose any mass. There can be no matter unaccounted for. But for right now, I just want to talk about why this is a chemical reaction, what's happening, and how it happens. In short, when you perform a chemical reaction, you are actually changing the molecular makeup of the original substances, our reactants, and rearranging those atoms to create new substances. That is chemistry. You use the same building blocks to create new stuff with totally new properties. And if we look at the evidence, we're able to form claims about exactly what's happening, which is what we did in class. Hope this helps as we continue to talk about chemistry. And next time you eat cookies or candy or drink a sugary drink, or do anything involving sugar, I hope you think about it just a little bit differently, because chemistry is all around us. It's in the food we eat, it's in the air we breathe, it's happening around us every single day. You guys have a great day. We'll see you later.